about the technological advances that has happened over the past 1 month. I invite my colleague, Mr. Mohammed Taha, to handle the Tech Bites.
Thank you, Artima. Good evening, all. I am Mohammed Taha, working here as a creative designer. Let's have a quick look at the technology updates that happened over the past month. First one is Google's open source website. Google launched their new website to showcase their open source projects and processes, and which include their policies and procedures are informed by many years of experience and lessons they have learned along the way. Next one is Apple's new file system. Apple rolled out recently their new file system APFS, and it puts putting an end to their 31 years old hierarchical file system HFS, and APFS is now designed to scale across a new type devices and to take advantage of flash or SSD. Next one, Gitter is joining the GitLab team. Gitter has been acquired by GitLab team. GitLab says that that's their strategy plan to become most popular SaaS solution provider for public repositories. Gitter will continue to operate as a standalone network. Next one, Google reCAPTCHA. Google's new version of reCAPTCHA doesn't need challenge or checkbox. They achieved with this combination of machine learning and advanced risk analysis. Let's have a look at the video.
Since the launch of the No Captcha reCAPTCHA, a simple checkbox has helped identify humans from even the sneakiest bots, stopping billions of attacks on websites around the world. But to stay one step ahead of the bad guys, reCAPTCHA needed to keep evolving to ensure the most delightful user experience. And now we're taking it even further. Can you see it? Of course not. It's invisible. Powering these advances is a combination of machine learning and advanced risk analysis that adapt to new and emerging threats. So whether on desktop or mobile, reCAPTCHA still means no frustration. People get to where they're going faster, and everyone stays happy, except bots.
Okay, next one is Angular version 4. Google has released their popular Angular JavaScript version 4. There is no version 3. They have skipped to version 4 in order to sync up with their Angular router version that's already in version 3. That's all for today's Tech Bites. Thank you.
Thank you, Taha. The highlight of this edition, the session on Docker, will be handled by Mr. Amal Dev, Technical Analyst, UST Global. He is a full-stack web developer with over 10 years of experience focusing on Microsoft technologies. Being a passionate developer of web and desktop applications, he is currently involved in delivering applications for enterprises which include Fortune 500 companies. He won the Microsoft MVP award in 2016 for his exceptional contribution to the development community. He's an active blogger who regularly writes about technologies such as ASP.NET Core, Docker, ASP.NET MVC, and many more. I invite Mr. Amal to handle the session.
VMs and containers, and then concepts in Docker, what's the best practices, and what are the use cases where you can implement this containerization, and what are the options you have for hosting the Docker containers in the cloud. And as also, I hope to show you some demos. I have some lined up for what all thing I am going to discuss here. So, have you have any idea about containers, or have you heard about the term containers? Yeah, fine. Now proceed. Okay, good. So, before going into what containerization is, I will go to the early days where how do we deploy applications in the servers? Okay, right. So in the early days, what we were doing is we have this installer package, and we will have a server where we will install the OS first, then we will install all the dependencies and all the prerequisites, and then we will install our application. So uh, these were the seen in the early days where the computing gets started. These were the typical architecture of a production server, where the underlying physical server, the hardware, and the operating system, maybe Windows or Linux, and the application lying on top of it. So, can anyone tell what's the disadvantage of this particular uh, layer or layering or setup? This setup. What was the disadvantages of following this approach? Anyone? Yeah, Nikhil. Yeah, that's right. There are a lot of disadvantages. One of the main thing is that one thing, if you want to scale your application depending upon the load, or if you want to upgrade the server, it was very cumbersome. There was a lot of technicalities involved there, and also you need to manage it physically. You need to have separate staff for maintaining this particular uh, setup, and also these ones are mostly dedicated for a single application. So that means there are a lot of wastage of resources. Most of the time the resources will be sitting idle. So what we are normally doing is we go for a high-end system for the maximum load, and in most of the times we were having a medium to low load, and a lot of resources were waiting, were sitting idle at that time. So that was the disadvantage of this approach. So let me have the. So as I said, these were the main disadvantages of using this particular approach. So then came virtualization. So again, what virtualization is? What is virtualization? Yes, someone? Misha? Misha?
We will be running more than one OS in a host operating system.
Yeah. Uh, Virtualization enabled us to uh, virtualize the hardware. That means we can share the hardware between multiple installations. So we were able to install multiple, or we will be able to set up multiple OSs on top of an OS, which virtualized the hardware. That means it shared the hardware. So the structure from the earlier one changed to this particular one. So again, we had this physical server, and we had an host operating system that can be Windows, that can be Linux or anything. And on top of that, there was an hypervisor. So, and the hypervisor was the connect between the upper layer and the host operating system. So on top of the hypervisor, we were able to install multiple OSs, and that to different OSs. So the host operating system can be Linux, and on top of that we can install Windows, any version of Windows, Linux, etc., etc. Any OS that can be installed on top of the hypervisor. and it was the duty of this hypervisor to communicate with the host operating system. So uh, the advantages of this approach was the utilization was improved. So there was no such resources were waiting idle. We were sharing these resources, and since there are multiple virtual machines or installations of our applications are there, we were able to reduce the number of machines. So with one virtual machine, and if you have 3 applications running on the virtual machine inside a physical server, so from the earlier approach there were 3 servers, now we have 1 servers and we have virtualized the hardware there. So it was very easy to maintain. So in that time, upgrading an OS or updating an OS periodically was very cumbersome task as well as a time-consuming task. With the virtualization, you were able to do it much more efficiently, because instead of time spending for upgrading 3 machines, you only need to upgrade only 1 machine in this. So these were the main advantages of this one. So what were the disadvantages of this approach again? It had some. So one of this, even though it was sharing these resources, as number of virtual machines, if there are say 6 or 7 VMs installed on a particular server, it increases the allocation. That means we need to, the host operating system need to give allocation for each and everyone, right? So again, if it's not a high-end system, then the experience is affected, and that way also we need to have considerable amount of storage and RAM for this one. So that means as the number of VMs increases, the uh, efficiency or performance is affected. That was the one of the main disadvantages. And again, as I said, there was a host OS, and all the communications was going through this particular OS only. There were no sharing of the resources inside the OS. So then came the containers. So what container is a what container is? It's basically again extended the virtualization technology we used in the virtual machines to a next higher level. That means now the OS itself is shared. OS itself is virtualized. So that enabled us to uh, run multiple instances of the contain or the multiple instances of the containers in the operating system. So basically it shared the kernel. That means there will be only one operating system, and all the rest of resources were shared between the various containers instantiated in that environment. So let's see. Uh, this is the architecture of a particular container. So from the virtual machines, we had this host operating system, and on top of that, we had a hypervisor. That's now gone now. So instead of that, these containers are directly interacting with the OS kernel. Yeah.
There was a physical server,
Yeah.
then a hypervisor.
Yeah.
On top of it, you are running virtual machine.
Yeah.
So why can't you run your containers within each of the virtual machine? That is also a plausible architecture, right?
Containers within each of the virtual machine. Yeah, that's also possible. But because of this hypervisor, every request goes through this hypervisor only, right? We are not directly interacting with the kernel or the resources of the host operating system. Now that's gone, and that requests are being directly interacting with the kernel itself. So since that middle layer is not there, the efficiency or the performance gets same. Yeah.
Amazon Cloud or something.
Okay.
Okay, so when they are hosting,
Mm-hmm.
they are not going to dedicate a host operating system for you on a physical server, right?
Yeah.
They'll be running multiple VMs.
Yeah.
So in those cases, okay, if you are using a container based on cloud, obviously the other architecture which I mentioned will be the default one, right?
Yeah.
So my question is, so when you say containerization, this is the default picture which people have got in mind,
Yes, this is the
eh?
default. Yeah, this
Not
is
the other one.
not the other one.
Okay, thank you.
So, so let's do a comparison between a container and a virtual machine. This particular container, the diagram is based on a Docker, and that's why the Docker engine is there. Otherwise, there will be a common daemon which will be interacting with the application and the libraries. You can see here that the hypervisor, and on top of the hypervisor we had this guest OSs, right? So and so that means in a virtual machine there was an OS for each of the virtual machines running on top of the physical server. With the containers, that is now gone. So one advantage of virtual machines was that we can have different operating systems. But coming to the containers, since we have since we are sharing the host operating system, all the containers will be running on the same operating system. That means if the host operating system is Linux, all the containers will be running on Linux only. That was not the case with the virtual machine. Okay. So on top of that, we have that our libraries or bin folder, and on top of that we have the application. Yeah.
How the Docker engine is different from the hypervisor. So we understand that there is an amount of translation between the guest OS and
Yeah.
host OS. I mean, that could be the role of a hypervisor in a VM scenario.
Yeah.
But in this case, in the case of Docker, what exactly the
Yeah. In the case of a Docker actually is a client server architecture. We have a client utility as well as a server part. So what in the case of a Docker, we will be creating the containers or creating the images, and we have this repository and a host. So that communication is handled by the Docker engine. In the coming slides, I will go in detail what the Docker engine, what's the purpose of Docker engine. With in the hypervisor actually was doing all the service calls, all those interactions with the host OS, and the guest OS was done by the hypervisor. But Docker engine is not doing that. Docker engine is doing a different thing that I will go through the coming slides. So, what exactly is Docker? Uh, Docker is built on top of container technology, and as you may know that containers were available in the Linux for a long time. That's called LXC containers, Linux environment, and Docker is built on top of that. So the technology was there, but with Docker uh, they have their own implementations which help the community to build and ship apps or build and ship applications more efficiently. Okay, so this is from the official documentation what Docker is. It's an open source engine that automates the deployment of any application as a lightweight, portable, self-sufficient container that can virtually run on anywhere. So their tagline is build once, ship once, run virtually anywhere. That's their tagline. So these are some facilities provided by Docker. It encapsulates the applications into a container. That's they are calling Docker containers, and it also provides the facility to distribute and ship those containers from a common platform. And also it also enables us to deploy these containers into any cloud providers. They have their own implementation, but we can deploy these containers into Amazon, Azure, or any other third-party providers also.
as a service.
Sorry.
So when you create a Docker container yourself on a Linux or a Windows machine,
Yeah.
so you can actually deploy on the cloud, means you can deploy on the infrastructure, right? Not on the
Yes. Yes.
platforms.
No, no. What basically they will provision the VMs and rest of the stuff and host the containers there. These cloud platforms. What basically they. So we have there is a level of abstraction. We are not exposed to what is happening beyond the underground. We will just push the repository. It will create the virtual machines and provision all those stuff, and it will host there, and we will get the hosted application as an output.
Got Kubernetes or something, right?
Yes, yes.
So a Docker container you create on your local machine will be compatible with that.
Yes, what basically happens is that I will create the Docker container or Docker image in my local machine. I will push to a public repository or a repository hosted in any of the providers, and they will take that build image from their from the repository and I mean
Feature, right? So my question is, Kubernetes will pull it, or the your Docker scripts will pull it?
uh,
You got my question?
yeah, yeah. What you are trying to ask is how Kubernetes actually install or actually host.
Is in a data center or cloud.
Mhm.
So when you say cloud, okay, it can be PaaS or IaaS.
Yes, yes.
So on an IaaS, I can easily understand. Okay, means Docker infrastructure will do that. Okay, there are scripts and those kind of things. But if you want to deploy on Google has got something else, right? And Amazon has got I don't remember which one it is. So these Docker containers are compatible with those PaaS offerings, or on an IaaS you can deploy. You got my question?
Yeah, I think we have both the options. We can do it from a Docker uh, platform, or we can directly using the Azure Container Service. We can directly deploy there. Okay.
These Linux containers?
Yeah.
Okay.
What basically they creates a Linux VM in the background. I will show. I have a demo for that too. So uh, this is the basic architecture which I was mentioning earlier. It's actually a client server architecture. In the client side, we have command line tools, CLI tools for creating Docker images or instantiating Docker containers, as well as a lot of other tools for pushing and pulling the images to and from the repository, etc., etc. So Docker, Docker is the name of the utility, and it accepts a lot of parameters. Docker build will build a Docker image. Docker pull will pull a repository from the public registry, etc. All those stuffs. And Docker host is the Docker engine. So whenever we execute a command in the client using the client utility, it directly contacts the Docker daemon. So if my command is for creating an image, or for say pulling an image from the repository, what basically it does that it in the host they have a local cache. It will first search for the image in that cache. If that's not available, it will go to the repository, downloads the image to your local cache, and uh, local cache. So once that image is pulled into your local cache, you can create containers based on that image. So for that, you will create Docker run command, which will create a container based on the image and uh, run the application. This is the basic normal workflow happening in a. Yeah. We can have different types of images based on Ubuntu, based on Windows.
Yeah. So, no, my question, my confusion is basically this. So when you say your Docker host, right, that is running on top of the host operating system,
Yes.
correct? So your host operating system basically is going to be a Linux operating system. And so when you pull this image, right, are you pulling the entire Ubuntu again? So if I say if my host operating system is Ubuntu, am I pulling down the entire Ubuntu again as an image and then creating a container on top of that and then running that? How does that, what is that image thing?
Yeah, the image contains, as you said, the entire operating system. It's a subset of the operating system. So what Docker follows is the containers follows a layered file system, right? So when you first download, when you download the image for the first time, it will download the entire huge file size. I think that's around 600 to 1 GB. Yeah, and so what happens is that when there is an upgrade to this particular image, okay, so what is happening in the background is that it only downloads the differential part. So whatever is changed is only downloaded. That means it is maintaining a layered file system. So in the first time there will be the file size will be larger, but subsequently it will be lesser.
One follow-up question.
Yeah.
So, so when you basically, you've downloaded the image, right? And you've installed the container, you've created all your layers, right?
Okay.
And when you do Docker run, right? So this is going to be running on your host operating system,
Yes.
correct? So when you're running on your host operating system, is that container entirely self-contained in the sense that it has the entire operating kernel, everything inside it running?
Yeah.
So isn't that kind of like a VM, right? It's an operating system within the operating system, correct?
Yes, it's an operating system inside an operating system. But the difference is that, as I said earlier, both the OS should be same, unlike in VM.
Okay, so it's not possible to then run, say, Windows image on a Linux operating system.
Yeah, we can do that, but for that they will use third-party tools like VirtualBox or Hyper-V.
And that becomes a VM anyway.
Yeah.
Okay.
So we can have Linuxes running on Windows and vice versa, but the catch is that it will use third-party tools like VirtualBox and but in Windows Server 2006 and Windows 10 anniversary update, the Docker support, container support is there by native. Native support is there. They won't need any VirtualBox like what we have in Linux.
So for Windows 10 anniversary update or whatever the update is, that basically means what you're saying is that you can actually run Linux natively on it.
Yeah.
Oh, awesome.
Hello. Okay.
Yeah.
So I'm just confused there. Okay. So the earlier slides pointed out that on Linux, okay, on Linux, not daemon, okay, Linux Docker container, okay, on Linux VirtualBox or a host OS, you can run only Linux containers, right?
Yeah.
So now in the discussion, I understood that on Windows 10 anniversary edition, there is built-in support for Docker.
Built-in support for Docker. They are support natively.
The Windows 10 will act as some kind of a host OS for the Linux OS which hosts the Docker.
Yes.
Like that it works.
Yeah. So as I said, there are images and containers. So what is image? What is an image and what is a container? So if I use a programming parlance, I can relate image to a class and container to an object. Okay. What image is it's basically a blueprint of what all things, what are properties it have. We will define that in the image, and it's normally after once that is created, it's normally stored in a local repository or a public repository or a private repository. So what containers is we create containers based on those images. Suppose we have a chair class and we create an object. So we create an instance of that particular image. So when you say we have containerized an application, so that means we have an image, and we based on that image using Docker CLI tools, we created a container which is ineffectively running the application inside that container. It's an isolated process. It's not. It's an independent thing, and it's not dependent on any other thing. So it can run on its own. it has got its own file system, storage, memory, etc. etc. So, what are the commands available for me in Docker CLI? These are the major commands available in Docker CLI. The first one is the Docker version, Docker hyphen hyphen version, which will show you the current version installed in your machine. And Docker hyphen hyphen info command will list all the information such as version and other metadata saying that what's the guest OS, host OS, etc. All those stuff. It will list there. So the Docker images command is used to list all the images that you have in your local machine. You can use the Docker images command to list that. So to view all the running process, you can use Docker PS command. It will list all the currently running containers. And Docker build and run is used for building the image and running the containers. And these items are basically related to the repository thing. Has got a public repository called Docker Hub. So where it's actually free for use, but you can't create private repositories in a Docker Hub. That you need to have a paid version. So from the command line, you can use Docker login to log into the Docker repository, and Docker search is used for searching all the images inside the Docker Hub, and Docker pull is for pulling the image from the Docker repository to your local machine. Docker push is doing the vice versa thing. That's pushing from local to the Docker Hub. And Docker tag is used for naming the Docker images. Say you can have different versions of the same image. So you can actually in your local repository you can download those images and you can use Docker tag command to tag to give you a friendly name or a meaningful name for yours. So these are the main commands which I'll be showing in the demo how it can be done in these commands. So yeah, yeah, Shane.
Certain, you said you would bundle certain OS elements as part of the container, right?
Yeah.
Wouldn't that be a license infringement, especially if it is, I mean, how is that taken care?
Yeah, from the Linux perspective, there are not much of that. That's an issue, right? License part. But coming to the Windows part, Microsoft has official images. They have published official images for Windows Server and Nano Server, and it's for reuse also.
Okay,
I
but
hope, yeah.
have all the dependencies that your application is that ensured with those two images? You essentially could bundle anything that has dependency with your application.
Only the code dependency, right?
Yeah.
Because SQL Server is necessary means it has to be in other.
Yeah. Suppose if you need to have SQL Server, you need to have SQL Server installed in this container, or you have options for SQL Server Docker images. Yeah. Sorry? No, it's not a best practice. Actually, we have containers for SQL Server. So from an application standpoint, you have two containers: one container for your application and one container for your SQL Server. And we have an SQL image for an SQL Server.
Messaging server you refer it.
And I think that's a web developer version. That's a free part of that.
Okay. Just one more question.
Yeah.
Is this bundling like dependencies being done automatically, detected automatically as part of your containerization? I mean containerization.
Yeah, we have options for linking the containers. So suppose if I have an application which has this web application part and as well as a database part. So I have two containers. So what I will do is that I will create. When the image is created, I have the option to create linked containers. So whenever the application is pinned up, it will pin up both these containers at once.
No, in terms of tracking dependencies, would the developer have to manually detect, I mean, list down everything and then ensure it is packaged, or would something automatically or intelligently do this dependency detection?
Uh, yeah. In the demo, I will come to that part, China. So that will be much more. So in this particular workflow, I am going to create a simple application. Okay, what it will do is, it will first retrieve since the cache is doesn't have anything, it will retrieve the item from the registry, and then it will create the container. So first, I will say, I'll suppose I want to create a .NET application. So I will say I will execute a docker pull command, and the pull command has an argument which you need to specify. That's the name of the repository. Normally, one of the best practices for creating the Docker images is that you have to have the first part as your username, the repository. Suppose you have Amal as your username. In the Docker repository, you specify create the image as Amal slash name of that particular image. So for .NET, Microsoft has named it as Microsoft slash .NET. So for downloading the .NET image, I will say docker pull Microsoft slash .NET. So when that command is executed, the Docker daemon will check in the cache. If it's not there, it will go to the registry and it will download that to the your local cache. Okay. So we have the sorry. So we have the .NET image in your local cache. Now you need to run this image. Okay. For run this image, I will use the docker run command. When the docker run command is executed, the Docker daemon will see that the cache, the image is there, and based on that image, it will create a container. Okay. Shall I go to a demo from here, or continue with the topics and do the demo all at once? All at once. Okay. All at once or demo in between? Demo in between. Okay. Okay. Okay, so I have a virtual machine which is running on Linux, Ubuntu 16.10, I guess. Yeah. Okay, so let me see. So what I will do is that I will there is a hello world container uh, in Docker repository. What it will do is when the container is executed, it will output hello world to the console. Okay, so I have deleted that image from my local. So to pull that, I will say docker pull hello. So I executed docker pull hello hyphen world. Uh, so as I said that the images can have different versions. So if I doesn't specify any version alongside this image name, it will always pull the image with the latest tag. That's the first statement. You can see that using default tag latest. And since this image has got only one layer, it has downloaded that to my machine. And if I execute Docker images, you can see that.
So, so hello world is not a operating system.
I'll go inside that container once it's created. So I will say docker run. So I just give docker run hello world. You can see this message that hello world, hello from Docker. Okay. Uh, so to view the running containers, I will say docker ps. So these are all are the current running processes. Looks like that. To view all the stop containers, Docker PS will list only the active containers. Okay. If you give Docker PS minus hyphen minus a, it will list all the processes that are stopped as well as currently active. Okay. So since our container this hello world uh, is not Once that command is executed, it stops the container. Okay, that's why that's why it's not shown under Docker PS. You can see that here, it's exited 32 seconds ago. Okay. So let me go inside a running container so we can see what it will be. So I will say Docker PS. I have one container. So to go inside a container, I will say Docker exec. Docker exec is used to uh, go inside the container. So I will give a parameter minus IT. That means I needs to be interactive, and I will sorry. I will give the ID. This is the container ID. So you don't need to specify the full container ID. You need to specify the a starting string only. It will take the rest of part automatically. And once this command is executed, I say that I needs to go to the command prompt or the bash prompt. So when that command is executed, you can see that I am running as a root inside that container. So this particular command prompt is from inside the container, not from the guest operating system, host operating system. Sorry.
So my question would be then, can I do a Docker exec on hello world?
Sorry.
Do this what you just now did, right? Docker exec dash it.
No. You can do this only from a running containers, only from the active containers.
Can we keep is there any way to make hello world running all the time so you can actually get into that image?
Yeah, we can create a new image based on the Docker hello world image and just keep open a delay so that this container will be in active state, and by that way you can go inside that.
Okay.
Okay. This particular container is a web application, so there is a web server running inside that. That's why it's currently in active state. So if I go inside, if I sorry. So if I this the contents of the directory. Seems familiar. What all the contents? All the directories from the Linux home root directory. So actually, so if you type exit, you will come back to the command prompt in the host operating system. So that was a simple demo for a Docker pull. So our command actually pulled one image from the repository and created a container and run that container for us in the local machine. So yeah. No, it's actually an isolated process. Yeah, it's a sandbox. Whatever you do inside it's a container, it stays there. Mm-hmm. Yeah, we can mount a volume or mount a particular folder into the container. So by that way, you can share the files from the container between the container and the host operating system. No. Yes. So we'll see how we can create images using Docker. The command for creating a Docker image is docker build, and So for using the Docker build, you have a file called Docker file. Okay. The Docker file is a set of instructions which can be used for creating an image. Okay. Uh, is it visible, this part? Yeah. So the first statement in the Docker file is called a from. Uh, that means that statement says that this particular image is based on a base image. You, whatever image you create in your local machine, it should be based on a image. It should have a parent image. Okay. So here I am creating a sample .NET Hello World application. So my base image will be Microsoft/.NET. So there are two types of images. One is the SDK, which will have all the tools for say .NET View, .NET Run, etc., etc. And the .NET Runtime, that's basically a scaled down version, which is used only, which will only have the runtime libraries. Which is useful, which makes sure that this particular application gets executed using the .NET framework. Okay. So once I specify that base image, I will specify a current directory using the work dir command. That will set the current working directory for inside the container. And once that, I now need to copy the source file, what all source I have created, to the container. Okay. So I have this app folder in my local machine, and using this statement, when the image is created, whatever is there in the app folder in the local machine is copied to the app folder in the container. You can give whatever name there. For the sake of brevity, I gave it as app. And once the entry point command is used to specify the entry point to the application, what command needs to be executed to run this particular container, that is mentioned in the entry point command. So here I am saying that .NET, that's the .NET CLI tool, and hello world.dll is the library which I have created in my local. So that should be the entry point for my console application. So first I will specify the Docker build. So it will have the Docker Microsoft.NET image, pull that image to my local image cache, and that was the first statement. And that copy statement will copy the my binaries to a container, to a layer inside the image. So this is the first layer and this is the second layer. Okay. So it copies that file to the image, and so when I specify the docker run command, the daemon will package this all the layers in the images into a container, and it will create a container for you. And when you give the docker push command, it will upload this container to upload the image to the repository. It can be a private repository or a public repository such as Docker Hub. Okay. So So I'll create a console application, say .NET new console. It will create two files for me, program.cs and one project file. I'll say after that, let's build this. First, I will raise the dependencies. So in this example, I will be copying the source code into the container. Then it will build that source code inside the container and run the application for you. Okay. So if I say .NET run, so it again just outputs only hello world. Okay. So I have already created one Docker file here. So yeah, what's the command for listing the contents? ls. Yes, minus. Sorry. No, I need to have the contents. So the first statement is from Microsoft/.NET. Then I copy the what all contents in the current directory to app folder inside the container. That's the work directory. The rest of the part is for a web application. I think you can ignore that. Okay, I think uh, this one. This one. If it's not there, it will create. Yeah. Yes. If it's not there, it will create a directory, sets it at the current directory, and then it copies it. So I think I will need to create a new Docker file. So let me. Otherwise, sorry. I will create a new file. I will create a new web application. So,
you haven't switched to the directory.
yeah. Okay. So let me restore it. So Docker build, and you need to specify the image tag for that particular newly created image. For that you need to specify the -t option, and I'll say demo web. Okay, and so you now need to specify the location for the Docker file. So Docker file, you can, by default the name of the file is Docker file. You can have a different name, but you need to, if you create it with a different name, you need to specify the name of the file using the -- file option. So now I need to specify where to look for the Docker file. So right now it's in the current directory, so I will specify that you have the so when that command is executed, you can see that the various steps. Okay, these steps are related to the commands in your Docker file. The first one, it pulls the image from the repository, and it created a intermediate container. Then it created the copied the contents from the local file system to the folder inside the container. After that, it sets a current work directory, and here it specified the environment variables. And so by default, the .NET run command hosts the application in the port number 5000. So I have override that one using this environment variable, and the expose command is used to expose the port number to the outside world. So I said that this particular, all the requests coming to this port number will be redirected to the web server listening on that port. And after that, that restore command is called. So I have copied the source file from the local file system to the container. Now I need to build that one. So for that, I first executed the restore command. It will restore all the packages mentioned in the references. And once that's done, you can see here is that the last step, entry point.NET run. So that's the entry point that will be invoked when you initiate a docker run command. Okay. So if I say docker images, you can see here that it's around 800 MB in size. So I have this simple application, but it takes around 800 MB. Right? Any guesses?
That .NET runtime.
Yeah, but actually this it's not actually this much. It doesn't have this much size. As I said, no, it's layers, and it's sharing those layers. So since I had already this .NET inside my in the local cache, it will share this. Sorry, where is this? Share this layer, and the rest of the items which I have installed, which I have restored, will take that space. Okay, so even though it's showing 800 MB, it's actually less than the size. All the runtimes, all the libraries related to the Microsoft .NET image, it reuse this image. Okay. So if you have say 5 containers running on the same image, all of them will show 800 MB. But in reality, it is reusing the underlying layers. Okay. So I will run this docker run it. -d is for run it in a detached. That means it will run in the background. And I'll say the name. I need to specify the port also. So inside the container I have specified that it will be listing on the port number 5001. Okay, so here I need to specify that mapping. What I will do is here I will see that whatever request coming into port number 5002 in my host machine needs to be redirected to the 5001 port in the container. Okay. So you can see that I have executed this rocker run command and it have created one container for me. So if I see I think machine is stuck. I think in the meantime we can break for coffee and after that look inside what we have inside that container. Okay.
Okay, so that was a pretty long session. Actually, we are delayed for the break, so ultimately what happened is that the coffee which has been served, it's it's not that hot. Maybe you'll have to deal with it. We are sorry. Okay, so this time there is a special. Actually, have you heard about Git Kraken? Anybody? Like we all know Git, but what about Git Kraken? Okay, so GitKraken is a product of Access of Technologies from Arizona, US. So they have associated with us, and this time all the goodies and all the swags for the event are being sponsored by GitKraken. So, so we have bigger goodies, like you will get T-shirts, you will get promo codes for subscribing to their product. So you have so many things in store for you. So basically GitKraken, it's a cross-platform Git client created for managing Git projects in a faster and more user-friendly way. So just to get a quick idea about GitKraken, we can just go to a video, okay? So please.
Welcome to GitKraken, a powerful new way to interact with your Git repos. This video will cover the basics of using GitKraken and is intended for users already familiar with how Git works. Let's begin. The push and pull buttons are on the toolbar here. This one will push the current branch, and this one will either fetch or pull the remote branches. You can set the default action by clicking here and then selecting one of the circular icons next to each option. Operations that involve two branches can be performed by dragging one branch onto another. This includes merging, rebasing, and even starting a pull request if your repository is hosted on GitHub or Bitbucket. Merging and rebasing require the branch to be on your local repo, which is shown by this icon. If it's not, simply double-click the branch to check it out, then proceed with your merge or rebase. Pull requests require the branch to be pushed to a remote repo, which is shown by these icons. Operations that are for a single branch can be performed by right-clicking on a commit. From here, you can create a branch, cherry-pick a commit, reset a branch to a specific commit, and revert a commit. If you right-click a commit that is the head of a branch, you'll have more options, which include pushing and pulling a branch that is not currently checked out, as well as merging, rebasing, and starting a pull request. Finally, if any of this goes wrong, the undo button will take you back to a previous state of the repo. This is really handy if you commit or perform a merge incorrectly and want to go back. You're now ready to use GitKraken, the free, standalone, cross-platform Git client. Download it today at gitkraken.com to unleash your repo.
Okay, so that was about GitKraken. You can just explore it if you want to. So basically we have a few goodies from GitKraken. We have the usual FAYA goodies. So those who give me the right answer for questions that will win the Git Kraken, we'll be giving you Git Kraken t-shirts. And for the others, we'll give the FAYA goodies, okay? So the first question, this is for a FAYA goodie, okay? Which is the first commercially available smartphone? What is the name of the first commercially available smartphone? Yes. Okay, this particular phone, it was a touchscreen phone. It has basic facilities like sending faxes, email messages, so the basic things. So, I'll give you the year. It was first developed in 1992, but it was a refined version of it came in 1994. No, the first ever smartphone. I'll give you a clue. It was something associated with IBM. Okay, the name of the smartphone, it is a name of a man. And this particular name, it has close connection with a freedom movement that we have seen. A particular slogan has this particular man's name. Okay. It's someone go back. Okay, but this no one gets the answer. No one gets a goodie. So the answer is IBM Simon. That is the first ever commercially available smartphone. So it had basic features like placing calls, receiving the calls, then receive faxes and emails. It had an address book, calendar, wall time clock, so basic things. It was a touchscreen phone. Okay, so the next question, which is the first graphical game? No. 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 This. No, I'll give you. Batman. No. I'll give you a clue. It had crosses and. Yeah, I got the correct answer from here. Okay. So you get a pen. Tic-tac-toe. That's the answer. Okay, another question for the Git Kraken t-shirt. So everybody is familiar with Git, right? So which is a command which was used to remove the stashed item? Those who know the answer, just raise your hands because, yeah, Mr. Nikhil. No. Another one. Yeah, correct. It's git stash drop. Okay, so please come to the front. So Deepu, if you could give the first Git Kraken t-shirt. Okay, so another simple question. Which is the language WhatsApp is written? Yeah, correct. So what's your name? Oops. Tony. Okay, so WhatsApp is written in Erlang. Okay, another t-shirt question. How can you create a branch and switch to it in one command? Sorry, I got the correct answer from here first. Okay, so. No, why should you do that? Because take it. No, you can actually take it and give it to someone whom you feel. Okay? So, Deepu. Okay, so another question for the t-shirt. What is a three-finger salute? Three fingers in in computer in computers. Three finger three finger salute while we are working with Windows. Okay, yeah, who gave the right answer? Okay, Mr. Shine Savior. Okay, the right answer is Control Alt Delete. Yeah, you get a T-shirt. It's the right answer. How did you guess it? You knew it already? Yeah, we do it every time. It's just three fingers. So Deepu. Large. Another question, the last one. It's not for the T-shirt. Uh, what language is used in Git? What is the language used in Git? Yeah, it's written in C. I'll give it to Mr. Nikhil. Yeah. You get a fire pen. Yeah, he obviously has a collection. He gets it every time. Okay, so thank you. So well, that's it. Thank you. So Mr. Amal can continue with the session. That T-shirt is fine. Okay, so if you want to know more about Git Kraken, you can actually go to this link and create an account of your own and use a promo code which is given at the top, meetup4417IND, and you will get a $10 reduction. So if you want, you can use it. So that's it. No, you get a $10 reduction. It's $60. No, no, no.
demo I showed I copied the entire source the container. I built, restored and built that project inside the container itself. So anyway, that's not a best practice. So what normally we are doing is that we will do our development in my local. We'll create an installer package. We are deploying the binary only to the production server, right? So simulate that in this demo, I will be the base image as Microsoft.NET runtime. That's how we specify the tag. It will be a subset of the .NET which needed for executing the compiled app.
Some place to resolve it, right?
Yeah, that's done by the Docker host, and it is connected to the Docker public repository. That's Docker Hub. Yeah, yeah, I can show you the Microsoft.
Okay. So it is not specified. So I was wondering all this time. Okay. Okay. So one more doubt, Amal. Okay. So when you say image,
Will have all the images.
okay. So my question is, okay, when you say Docker container, okay. So image means, okay, you have got image for .NET runtime, you have got image for different executables.
Yes.
Okay. And the container is nothing but when you execute that bash script, okay, you create an instance of it, okay, that's
Yes,
what, right?
yes.
So there is nothing called a Docker package.
No.
So there are images and then a Docker file, and a client runtime will just sequentially execute and then create it.
It's just like the basic installer package we create. So that we create a Docker container which packages all those stuff into a container.
Okay, so it is some kind of a binary
Uh,
or a is it a zip file?
uh,
No, that I understand.
he know how that's stored. He needs. Yeah.
It's okay. I thought that okay, there is a bash script. By the mind. Okay, that's resulting process. The totality of that package is for container or some order of it. My question is there any packaging for the container? Not for the image. Okay, images are okay. There are 6 images, then all 6 images compositely form one category. So will it be a folder or is it a let us say packing mechanism like RAR or this? That no no. No, images is are this for the registry. Right, I understand. And also
The local cache.
that's a cache. Okay, so that for the time being we'll resolve it as a composite one. Or else okay, we decide that it is taken from the cache. So my question is, when you run a Docker file, you are actually pulling all these files into some kind of a folder, right? So are they packaging into some kind of an LXC binary?
That I need to go into how it gets stored in the actual file system. That's your question, right?
Or else it is scattered in folder and then when you start, okay, dependencies are. Okay, so you mean to say that okay, when you say a container, it means host plus the resulting environment. So this layer is creating confusion for me then. See, there should be some kind of are you able to follow my question? Okay, there is a repository which contains 6 different packages, and I am supposed to create that container, which okay, is an ensemble of all those packages. So when I download, see some kind of the client will actually execute the Docker file, okay, by looking through it. So are they storing things in different folders, or are they having some kind of a are running in some kind of a container or some kind of a tube or something? Okay, where in it, are they running it inside a stripped down environment or something, or some kind of a binary tag?
Okay. Uh, this is a stacks available for the Microsoft .NET image. So you can see that different versions, different labels are there for Nano Server, runtime, etc. Those all are for Windows and Linux flavors. If you are running on a Windows machine or a Windows host operating system, you should go for a Nano Server thing. Otherwise, you go for a so. Coming back, I'll copy all the deployed library, generated libraries into the folder, and the rest of the contents of the file are similar to what we have seen now. Okay, setting it as the work directory, and then so let me create a web application first. Uh, what I'm basically doing here is that I create the deployed binaries using the release configuration and into a folder called deploy. Okay, so you can see that all the DLLs and the content files there. All the content files only. No source code is there. So I will say docker build. So I gave a name, and you can see the difference between the earlier approach and this approach. There are no installations, only just it copied the files and it exposed the environment. I mean the port number. So to run this, I will say So if you execute docker ps, you can see here that, right? So I have created the port mapping. So whatever coming at the port number 9000 in my local machine will be redirected to the port number 5002 inside the container. So let me access that website. Take any IP address there. Let's take some time. So in the meantime, let me go inside that container. Docker. Surely the current directory will only have what all files we have copied from the deploy folder. This one is running on this local machine which connected to the port number 9000 in the Azure VM, and from there it got redirected to the 5002 port inside the container. That's the flow here. So again, one more thing. So one of this advantage of again this approach is that suppose I need to modify the static files. Okay, so how will I do that? Because all my content files, all the static files are I have copied to the container, right? So again, it's not a best practice actually. You need all. It's not a best practice to save the data inside the container. You need to save that outside. That's because this container can be stopped at any point of time. When that happens, all the data will be lost. That's why they say it's not a best practice to save the data inside the container. Yeah. Yeah, it's saved as a layer. Suppose I have a container. I have all the files inside that container. I accidentally stops that container. All your data is gone. But the data is not there. Data won't be. No. The persistent data won't be there, I think. again, coming to that point, what if I remove that container? I think if it's restarted, the data will be there. But if I remove and create a new container, all the data will be lost. Okay. So let me see. Let us see how we can create. How can mount a volume from the. Yeah. Okay. I have only one more demo left. So what I have done is very similar to what I have done in the previous example. The only difference is in the Docker file, which doesn't have the copy command. I pull the base runtime, then I set the current working directory and set the expose the port. I don't have the copy command. To remove a container, you can use the docker rm command. Okay, so docker rm, you can either specify the container ID or the name itself. So it will say that it's in use, so you can specify -f, so that it will forcefully kill that container. So looks like is something there. Okay, you got the idea, right? You can specify minus v to specify the volume. So what will happen is that you will map the this volume in your this folder in your volume in your host machine to the app folder in the container. So you can make whatever changes in your local folder, it will get reflected in the application. Okay. Yeah. No, you need to specify the volume while running this command. Yeah. I think I tried, but I was not able to. There was some. Also, the documentation was also not clear on how. They were saying that we can do that, but I think that. Yeah. So there is one more tooling called Docker Compose. Okay. How it's different from Docker build is that, as I said earlier, there may be scenarios where you have multiple or linked containers. Say your web application may be having a web application part as well as a DB part. Okay. What normally we do is that we will host the web application in a separate container and we database in another container. But while deploying this, we need to have these two deployed simultaneously. Okay, for doing that, we can make use of the Docker Compose tool, which in which we can specify a lot of options. Okay, by default, Docker Compose looks for a file called file with an extension YML. You can specify any name, but by default, it will use docker-compose.yml is the default. Otherwise, you can specify any name, and you just need to specify while executing the Docker Compose statement. So this is an example file. Let me show that from my code. Okay. The Docker Compose file has called section services. Under the services, you will be specifying the configuration for your containers. So here I have created one for web app and one for my service. Okay. So for the web app, I say that for building that, you need to look under this particular file. You need to use this particular Docker file, and what should be the name of that particular container, and you can also specify the environment variables. Earlier we were using Docker file to specify the environment variables, but you have also the option to specify a environment file where you can specify all the environment variables. And the next one is the crucial thing, depends upon. It mentions that this particular service is depending upon another container called REST service. Okay, and there the one is a port mapping which we use to specify in the docker run command, and after that it should I am specifying the network. So it will create a network with this name, build app network, and for the REST service also for the REST service So under the network steps, I have created that network and set the bridge driver as the bridge. So how will we execute this file, right? For the Docker file, we are using Docker build. For creating these services, we use the Docker compose. So when I specify the Docker compose, it will take this Docker compose.yml file and send to the Docker daemon. So when that command is executed, it will first look for the depends on tag. So here it's the first multi-service is depending upon a web API thing. So what the daemon will do that, it will first create this web API container first. Okay. After that, it's created. That's why it gets highlighted here. When that command is executed, it will look for the depends on parameter and it will create that container first, that image first. So after that, the first image is created, and you will have now two images based on the compose file. So for creating this command, docker-compose build. Yeah. Means you can specify multiple items here, and it will execute in the order which we have specified there under the depends on.
No, is it one level or is it a hierarchy tree?
No. Suppose for web API depends upon another container. You can specify that also there. So yeah. To create the container based on this Docker compose file, you have the command called docker-compose up. It will create the containers.
We can write a batch file to orchestrate composer as well.
Yeah. You can write a batch script file and do that also.
So that will actually
Yeah. It will do that. Okay, you can see that this linked icon. So when the container is created, it will create the individual component first, and then the other one which are depending upon the container. So these are some of the best practices you need to follow while developing apps using Docker containers. First and foremost, don't store the data inside the containers. Use volume mounting, or otherwise there are options to create data containers. Okay, in that it stores only data, which doesn't have anything. You can mount that container, or you can create a dependency container for your parent application. And another one is don't deploy applications into running container. Again, the issue is that if you stop the container, it will be lost. So, and also it increases the size also. And another best practice is that you need to use a container for only one thing. Okay, so if you have to do multiple things, you need to create different containers and link that. And also one other, don't create a container with only a single layer, one huge layer. It's best it's advised to create images with multiple layers, so that it can, one of the advantages, it can be shared if we are using a similar type of application. And another one is that create hard coding IP address. See, we have created a linked containers, right? So suppose if I have hard coded, suppose in the second container I have installed a SQL server. and I have hard-coded the IP address for accessing this SQL server in my code. So the issue is that if you create these IP addresses are generated for the containers dynamically. So the one which worked on your development machine may not work in another environment. So it's advised to don't hard code the IP addresses. Again, credentials. It's a common thing, right? We are not, as in other scenarios, not advisable to store credentials in the image. And also, yeah, in one of the examples, I copied the entire contents of the file from the host machine to the container, right? So in some cases, we may need to ignore some files or folders there. We don't need to copy the entire contents to the container. So you can specify a Docker ignore, just like what we have for Git ignore, in which we specify the files that needs to be excluded. So where are the use cases for this containers? One of the mostly widely used containers are widely used in microservices architecture. So, how many of you are aware that your e-commerce site is not a big monolithic application? It's composed of different microservices. Your cart may be serving from one container. Your command or review engine may be serving from another container. It's actually a collection of containers which list the contents inside a e-commerce or like your Flipkart or Amazon's of the world. The advantage is that if one system goes down, the entire site is not going down. And so Flipkart is conducting a big billion day sale, and they need to scale the application. So most of the load may be coming to searching the products, right? So they can scale up the containers that are serving that particular part only. So that's another advantage of using microservices, especially containers. Another case is continuous integration and deployment. So assume that you are in charge of creating deployments for your applications, right? So what normally happens if the business comes and asks, I need a new instance of the application. So we will provision one server, install all those stuffs, and install the application, prerequisite, etc., etc. That consumes maybe a week, right? But using containers with a single command, you can create an instance of the application, right? That's another advantage of using microservices. Again, similar cases with multi-tenant applications. So you can have different containers for each tenant in your application. And that's another one is the app isolation. So if you want to host an application in an isolated, which doesn't have any dependencies with the related a framework or the platforms, you can use that too. Yeah. 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 How secure is? Yeah. No, I am not aware of. Yeah, because one of the this is hugely, I mean, widely adopted even in the beta stage itself. This particular technology. So we are yet to face a calamity like this. Okay. I heard that. Yes. Uh, so these are some offerings for Docker hosting Docker in the cloud. Docker itself has an offering called Docker Cloud, and using Docker Cloud, we can actually connect to Azure or AWS. So Other than that, they have a native offering, so we need to set up the hosting server. Dot Cloud was the earlier one from which Docker evolved, and I think that Dot Cloud is shutting down, I guess, recently. So Azure Container Service is from Microsoft Azure. I think from Visual Studio itself, you can directly deploy to Azure Container Service. It will create automatically the Dockers, the underlying virtual machines, and automatically all the security policy rules, and they will automatically create, and you can host the application. Similar cases with AWS also. That's, yeah.
Yeah, so when we create virtual machine, we give the amount of memory, the CPU, the power of CPU, how much hard disk from the host OS to the virtual machine. That way, anything that runs in virtual machine is contained. How do we give the same restriction to Docker? So do we say that, okay, Docker use this much amount of memory, which is just for the process, or process plus OS? If that's not possible, then can one Docker instance starve another Docker instance by occupying huge memory from the host OS?
I think Docker has one option called Docker Swarm, where you can configure these options. Where if it's how much, if the, if the utilization is higher, then you can scale up another instance. From the Docker Swarm and also from Docker Cloud also, we can do that.
Yeah, so when you say memory for Docker, is it just the Docker application or including the host OS? So for VM, we know that, okay, 300, 400 MB will be used by the OS.
Yeah.
When we do Docker, do we have to worry about the memory of host OS?
That I need to check up. I haven't gone through that in detail yet. I'll get back to you.
You just mentioned about sending data coming to port 9000 to 5025, something like that. So can I have two containers which take data from port 9000 and process it?
So
No.
you have mean to say that you have port 9000 open in your host machine,
in host machine, and
you need two containers to access this.
yeah, yeah.
I don't think so. It's not possible. That's why I got the error second day, right? It's already listening to this
Okay.
port.
So actually the Docker is accessing that particular port, right? And then forwarding the contents.
Yeah,
to
actually the Docker engine is forwarding this request coming in to the 9000 port in my host machine to the 5000 port in the container. The Docker host is doing that.
So basically Docker has control over it.
Yeah, it's a daemon running in the background.
But it doesn't forward to multiple
No.
containers.
Okay.
We can deploy multiple web applications. So it's related to ports. Say it's related to ports, right? Port.
So so suppose you have two web applications, right? So suppose say your web application, take a case of the classic scenario. Your web server is there and you have hosted two web applications in the server. Are they listening on the same port or on different port?
In a shared server scenario, it uses same port. So I need to host two domains.
Port should be different, right? There will be two different. Port
But
will be different.
URL will be will be same. URL. So I need to host two subdomains. Say something .test.com.
Okay.
So it should listen in the 80 port itself.
So you have two subdomains for your application. Okay, and you need to map that two subdomains to a two different containers. Okay. Yeah, you can go for a reverse proxy, which does which will do the load handling and the port forwarding. Okay, it will you will specify the port 80, which will lands upon the Nginx, and based on the request, it will redirect to the containers which you. No, they will redirect to two different containers. We can do that, but I think it's not recommended.
Yeah, regarding the best practices section, you mentioned like you shouldn't be hard coding IP addresses, as well as you would be having certain server-side resources, maybe printer names or printer queue names and all. Is there a way to kind of dynamically map this to when the Docker starts?
Yeah, you can actually use the environment variables for doing that. Otherwise, you can use files which can, using the volume mount, you can read from that file instead of hard coding those values in the code itself.
If you use config files, this will be specific to each environment, right? So which means that we'll need to maintain config files per environment. I think one of the things that we are trying to solve using containerization is that I build and ship something and then I can deploy it in any environment.
Yeah.
So if you have config files outside the container, isn't that actually a problem?
Anyhow, if you look at the classic scenario, you will be anyway keeping multiple config files. So for release, for QA, you will be creating different files, right? Similarly, we need to create, suppose if I need to a QA instance, I will, while creating this particular container, I will use this config file.
So we will need to maintain config files for each instance.
Yeah. Just setting an environment variable will trigger appropriate sections. Yeah. Like in .NET, we. Anything? If not, I think, thank you.
So thank you so much, Mr. Amal. And if you have any more questions, you can ask him after the session is done. And thank you so much for giving us such a wonderful session, and it was really useful, right? Yeah, yes. Okay, so as a token of appreciation, I invite Mr. Deepu Vaisnath to give him a memento.
So I think it was that is, he was able to give us the cream of what Docker is and how useful it was. Yeah. So this session is intended to that is to solve the entry barrier for Docker, which is faced by most people. So that is, we can see a lot of people who are currently practicing Docker, and that is can get the basic idea, as well as you will have someone to support you if you face some problem. So this is just like, I think that is most of you are from the server administration and stuff, right? How many web developers are here? Okay. Server admins? Okay. Mobile developers? Okay. QA, testing? Entrepreneurs? Okay. So hope you will start, this could help you to start using Docker, at least make a try. Okay. And I would like to give you a couple more updates about FAYA 80. How many of you are new to FAYA 80? Okay. So that's very less in number. Initially, Arnima was telling like a lot of people are new to FAYA 80. So this was the 47th edition, and next month we will complete 4 years. And on the 50th edition, that is on July 5th, that is actually we were associating with NASCOM, right? NASCOM would like to take FAYA 80 Pan Kerala, that is to Cochin and Kozhikode. So it will be the session repetition. For example, that is it is not like every month the same session happens all the 3 locations. It will be like that is previous sessions that happens in Trivandrum, that is it will be replicated with the same speaker at Cochin and then in Kozhikode. Okay, so we are also planning for a bigger event for the 50th. Don't we need that? Yeah, we can plan for a one-day event, and that is we want to make it really wonderful. So we plan to create an organizing committee for that. So it will be on July, that is we have 3 months lead time, and we really need your suggestions. So those who want to be part of that organizing committee, please raise your hand. Those who would like support. Okay. Okay, great. So what are your suggestions for the 50th edition? What could we do? Yeah, sure. So that is those who want, can support us. Please stay back after the session so that we can have a quick discussion on what exactly we can do on the 50th edition. Okay. So I would like to invite Rajiv to hand over the gift. It is a very small gift. I want him to open it and see what it. Also, that is I think that is most of you know about our Facebook group. It is called Techno Geeks, and please do join that to keep updated with the future events. Okay, thank you.
So that's it for today. We thank you for sparing your time and being with us, and hope you enjoyed the session. Hope we met your expectation about Docker. And FAYA 80 is just about bringing like-minded technology enthusiasts together so that you can create a bigger network among yourself. So I hope that this will open doors for you to get to know more people who are experts in various technologies. So that's it. Once again, thank you, Mr. Amal, for helping us get a stepping stone for Docker, and thank you all. And please don't forget to give us your feedback. So we'll be sending you feedback mails. So you can just send us your feedback about how the session was, or if you have any suggestions regarding the topics that can be put on for discussion in the future events. So, and if anybody would like to be a speaker for the upcoming FAYA 80 events, you're free to talk to us. We actually provide an opportunity for everybody to share what you have gained or share the knowledge what you have. So that's it, and join Techno Geeks. Okay, you.
So all the FAYA 80 sessions are online. That is, it is available in our YouTube channel. Initially, it was known as Coffee at DBG, and after that, his company got merged with FAYA. We changed the name as FAYA 80. So if you search for FAYA 80 itself, you can see all the sessions that happened previously. That is, it ranges from all the JavaScript frameworks, that is Angular, Ember, Knockout, etc. That is, we had Python session. We had Ruby, why Ruby? Okay, and Magento. So almost all the different types of topics we have touched so far. Machine learning, TensorFlow, then IoT, yes. Yeah, search engine optimization, QA, then automation, Jenkins, that is we had continuous integration, cloud. So lot of sessions that we had. That is, you can find it in our YouTube channel. All these even goes live. So even if you miss the session here, you can watch it live from your home, and it happens every first Wednesdays, 5 p.m. to 7:30. So every month it happens. Okay, and as I said, as she said, it is about making speakers from our community. Actually, we want more people to come out and talk, because most of the people, that is, whenever there is some new technologies arrive, the biggest problem is like people go for some coaching centers for that session. Actually, people who are coming as trainers there are not fully qualified to give us. They have textual learning and they just teach it. But actually, that is, we are the real experienced people who are authorized to talk, but always we have a hesitation like, oh, we are not good at talking. We are good at implementing, but we are not good at talking. So FAYA portability is like, it is a small group of people, so you can confidently talk and start sharing your what you know. And it is actually an open interactive session. It is not like a speaker should know everything. It is like, that is, we are having an informal gathering, and we try to discuss on what happened in the technology world last month, as well as some discussion on one technology to clear the mist around it. Okay, thank you.
Thank you. So if anybody didn't get the stickers of GitKraken, it's available.